All right, so well, for this problem, we're gonna simplify the given expression. We're gonna assume all variables are positive. Well, here we're talking about rational, radical, and rational expressions. It has to do with the end root and rational exponents. Now, in this case, we have, as we see, we have the radical. The radical is 3, so we have to look for perfect cube roots, right? And then we're gonna factor. We're gonna find the factors that are perfect cubes. Well, let's start with the first one here. Go step by step. So let's start with 81. 81 x to the 4th power times y, right? Equals. Now again, we need to find factors that are perfect cubes, so we can get rid of radical, since we have the radicals is the radical is 3, so it's going to be 27 times 3, right, times x cubed times x times y, right? For the second one, it looks perfect. The second one is already the second radical is already simplified, so we don't need to do anything about it. And here we're gonna go to the next one. So the next one we have inside the root, the radical is negative 3x y to the 4th power. So negative 3x y to the 4th power equals, well, let's take the negative outside here. We get 3 times x times y cubed times y. Okay? And now we're going to rewrite the expression using the product property of radicals, as we know from the rule of radicals. When we have let's see here, when we have the end root of AB equals the end root of A times the end root of B. Okay, so we're going to use this this property here. All right, so so now we're going to rewrite. Let's add. Let me add one more page here. Now we're going to rewrite the expression using the product property of radicals. So now it's going to be the third root of, well, third of 81 x power 4y minus 11 x to the root of 3xy plus 5 times the third root of negative 3xy to the 4th power. Okay? And this one is going to be written like this, all right? Since we found the factors that are perfect cubes, so and by using the property of radicals, so it's going to be written like this. Okay, 27 times 27 times x cubed, right, times third root of 3xy minus 11. This we do nothing for this one because it's already simplified, so we got 3xy and plus 5 times negative y cubed, right? And then we have, I think I need space here, so let me move a little bit this one here, and then times the third root of 3xy. Good. Okay, now we continue here. Well, this obviously we know that the third root of 27. We know that 27 is 3 power 3. So we can just like we can just like change the root of 27. So if you take Well, let's take one by one here. Let's take one by one here. Let's take one by one. So it's gonna be so this one. It's gonna be now 3 power x, because we know that 27. We know that 27 equals 3 power 3. All right. So the 3 will be gone here. So so it's gonna be 3x. Okay. Times. No, this so the second one is already simplified. We got 3xy will stay the same here. Okay, minus 11x, and this one it's simplified already. Okay. Now here we have to pay attention for the third one, the third term here. Okay. Now, well, 5 will stay the same, and we're gonna take -1 out. Because we have negative, we know that -1 cube, okay, equals -1. So if we have -1 inside inside the perfect cube, I mean inside the third root, so we can just like take negative outside if we have, you know, so it doesn't matter. So we have it's going to be -1 times y, okay? All right, so times 3, sorry, let me just, all right, let me just like, it's a little bit longer, that's why we don't have space here, but it's okay. Nope, I need to simplify this. Good. All right, so let's do this one here. Okay, you need to erase this. Okay, so let me erase this here. I cannot erase it. Okay, let's continue. Now here we have so 3, so this is gonna be 3x through the root of 3xy minus 11x times the third root of 3xy. Okay, and here, well, positive times negative, we have 5 times -1 will be -5 y 3 x y. Okay. Well, as we see here, we have the 3 terms. This is all like radicals, okay? But they don't have the same variable. They're not like variables here, okay? Well, this is the same, but this is different, all right? Now we can add the first term with the second term. So we can add the first term with the second term. Okay, we're gonna add the first term with the second term, and that's gonna be it's gonna be 3. So it's gonna be 3 minus 3x minus 11x. That's gonna be -8x. So that's gonna be -8x. Okay, the third root of 3xy minus 5y, the third root of 3xy, and that's going to be the final answer. Okay, if you want to factor more, we can just like you know, factor with this 3xy -xy -8x minus 5y. This is also correct. Okay. All right, let's go to the next example. All right, in this question, we need to rationalize the denominator. The idea of rationalize is to make it rational, right? The idea is just like we have to rewrite the quotient so that the denominator contains no radicals. All right, this is the idea. Now if the problem we have with the square root of 2, do we have to multiply by square root of 2? No, because if you multiply by square root of 2, for example, here, okay, So we're going to have a problem because we're going to multiply by 4, we're going to get 4 square root of 2. And we're still going to have a problem. So we need to do something that we can just, make, we try to make the denominator, will have no radical, any radical sign. So this is the point. Now, let me erase this here. So the idea that we multiply by square root of 2 is not going to work. Well, we can think when we have something a plus b, we look for a minus b. In this case, we need to know what is a perfect square. So we have to make it like a perfect square. Let me remind you about the perfect square. When we have like a plus b, now if you multiply by a minus b, we're gonna get a squared minus b squared. Okay? Now, let me just erase this. All right. So well, this is the idea here. So we can just So the idea here, we can just like think about 4 minus 3 square root of 2, okay? And we need to do the same thing here in the numerator, right? Because the 4 minus 3 square root of 2 over 4 minus 3 square root of 2 equals 1. So like we did nothing. So the idea here, the idea here, it's just not to change the denominator. We're just gonna rewrite it, and we'll make it rational instead of leave it like irrational there. So this is the idea here. And the best way to deal with this is to think about perfect square. Well, let's do some. No, let's start with the denominator here, which is easier since we know the rule. So it's gonna be 4 squared minus 3 square root of 2 squared. Great. Now we need to use FOIL, right? We just multiply 5 with 4, 5 with negative 3 square root of 2, and then we have negative square root of 2 times 4, and negative square root of 2 times negative 3 square root of 2. So 5 times 4 will be 20. 5 times negative 3 square root of 2 will be negative 15 square root of 2. And please forgive me about my handwriting because I'm using the tablet here and using my own hand, so it seems obviously. But I think the idea is clear, and you can see the written. It will be. I think it's kind of understandable and clear. All right, so let's go to negative square root of 2 times 4. That's going to be minus. Again, negative times positive will be negative. So that's going to be negative 4 square root of 2. All right, and then we have negative square root of 2 times negative 3 square root of 2. And so negative times negative is positive. So that's going to be positive. And square root of 2 times itself will be 2. So that's going to be 3 times 2. Again, let me just clarify this. Well, square root of 2 times square root of 2 will be equal to 2. Okay? So okay. So let's continue here. Let's just continue here. We have another page. Okay. So we got here we got 20. We got 20 and negative 15 square root of 2, negative 4 square root of 2. So both of them with the same sign. So we're going to add them up. We're going to add 15. We're going to add the absolute value and the negative of both values. It's going to be minus 19. Sorry, minus 19 square root of 2. And 3. That's 3 times 2 will be 6 here. Over the square root of 16. Well, the square root of 4 is 16, I'm sorry. And the square root of 3, I'm sorry, the root of the square of 4 is 16, and the square of 3 square root of 2, it's going to be 3 times, it's going to be 9 times 2, which is 18. So it's going to be minus 9 times 2. Again, what do we get 2 from? Because we have the square root of 2, so square root of 2 squared will be 2. Okay? So now we're going to add 20 with 6 here, and we're going to get 26 minus 19 square root of 2 over 16 minus 18. Again, here we have negative, and we have subtraction and multiplication. So priority goes for multiplication. Okay, and that's gonna be okay. 26 minus 19 square root of 2 over negative 2. Okay, we're just gonna combine like term. Well, here we get just gonna we can let's see if we can do this. Yes, so we can just remove the sign there. We can put in the middle. It's gonna be 26 minus 19 times square root of 2 over 2. I think this is the final answer. Okay. Now we just learned how to rationalize the denominator. Again, we don't change the value of the denominator. We're just gonna rewrite it in rational way instead of leave it as irrational. So the best way is to get rid of radical in the denominator. Let's take another example here. So I have this question. We get 3 over third root of 5. Now, well, here we have a problem because we need to rationalize. The question is rationalize the denominator. Excuse me. Now, the thing is, we need to think about the factor, that needed to make radicand. We need to change the 5 as a 5 power 1. How we can make it 5 cube, so we can get rid of the radical. Now we know this is power 1, by the way, right? This is like power 1. So what we need, I need 5 power 3. That's what I need, right? Now we know that 5 power 3 equals 5 power 1 times 5 squared, actually. Now I do have 5 power 1. I'm looking for 5 squared. So the idea is I need to add, all right? I need to add, if I can add this, the third root of 5 squared. And I will do the same thing for the denominator, so it's going to be third root of 5 squared. Okay, let me take this one out. All right, this is separate. Let me just erase it. Okay. Now, if now the thing is, if let's combine all of them, combine the denominator, so it's going to be 3 the third root of 5 squared. All right, here we have third root of 5. Now 5 power 1 times 5 squared is going to be, 5 power 1 times 5 squared is going to be 5 power 1 plus 2, all right, that's going to be 3. Okay, that's going to be 3, the third root of 5 squared over 5. All right, since we have the exponent is 3 and the radical is the radical is 3 here. Okay, so we can get rid of radical. So we get third root, and we get the exponent is 3, so we can get rid of radical. So that's going to be, this is the answer. This is the final answer. I think it's clear now. By the way, let me just let me just 5 squared equals 25. So this is not the final answer. Let me just all right. 5 squared equals 25. I have to write it down. Okay. Okay. So that's gonna be 3 third root of 25 over 5. This is the final answer. Okay. Alright, this is all set for today. I'll see you to the next video. Have a good day.